Lesson 11-5. Explore solids. By the end of today's lesson, we will be able to identify solids. The polyhedron is a solid that is bounded by polygons that enclose a single region of space. So, what you see down here is a pyramid. We can call that a polyhedron. Face means the polygons that make up the polyhedron. If we look at the pyramid down here, this triangle, this one triangle that makes up part of this polyhedron is considered the face. The edge is a line segment formed by intersection of two faces, so we call this the edge. And vertex is a point where three more edges meet. So we have this edge and this edge, so this would be considered the vertex. The base. The base is the polygon, which is at the bottom of the polyhedron, that is used to name the polyhedron. So this is what we call a square pyramid, and the regular polyhedron is a polyhedron whose faces are all congruent regular polygons. And a convex polyhedron is where any 2 points on its surface can be connected by a line segment that lies entirely inside on the polyhedron. So if we're talking about any 2 points, and then you connect a line, and then everything still lies inside and on the polyhedron, so we call that a convex polyhedron. Platonic solids, there are 5 in all, and this is just one kind, one of the 5 regular polyhedra. And if we go to your textbook, page 744, it lists the 5 types of polyhedras, or Platonic solids. Make sure you look into that. And cross-section is the intersection of a plane and a solid. So if I have a sphere, and if I were to draw a plane through it, the cross-section would be a circle. Types of solids. Polyhedral just means that it describes a solid that is bounded by polygons. So if you look at the prism and the pyramid, they're bounded by rectangles and triangles as their faces. But for the cylinder, the cone, and the sphere, they're not polyhedral because they have curved surfaces. So that's the main reason. Okay. Example 1. Tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So first of all, for the first one, we will call this one a tetrahedron. Because it has a triangular base, that's why we use tetra. And then the number of faces would just be 4. And the number of vertices, 1, 2, 3, 4 as well. And edges, 1, 2, 3, 4, 5, 6. So we have 6 edges. For part B, we have a hexagonal base. So because there's 6 sides, so we call this a hexagonal prism. And then there are how many faces? 1, 2, 3, 4, 5, 6, 7, 8, top and bottom. And vertices, since we have 6 up here and just 6 in the bottom, we should have 12. And edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 6 more makes 18. And then for part C, this would not be considered a polyhedron, so no, we write no because it has a curved surface. Therefore, we don't need to find the number of faces, vertices, and edges. Part D, the base is a pentagon, so we call this a pentagonal prism. And then the number of faces would be 1, 2, 3, 4, 5, 6, 7. And then number of vertices, we have 5 here, 1, 2, 3, 4, 5, and 5 in the back. So that makes 10. Edges, count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus 5 more in the back makes 15. And E, this is a cylinder, has a curved surface, so we say no. And the last one is, let's see, the sides are not all equal, only the opposite sides are. So we call this a rectangular. Remember, we named polyhedrons by looking at the base. Rectangular pyramid. And then to count the number of faces, it will be 1, 2, 3, 4, and 5. And then vertices, 1, 2, 3, 4, 5. And then edges, 1, 2, 3, 4, 5, 6, 7, 8. Theorem 12.1 is Euler's theorem, and it's actually a formula that's very useful. So it just states that the number of faces, vertices, and edges of a polyhedron are related by the formula where F plus V, faces plus the number of faces plus the number of vertices of a polyhedron is equal to the number of edges plus 2. So if you look at this cube, you have 6 faces, 8 vertices. 6 plus 8 equals E, which is, we have 12 edges, 12 plus 2, so 14 equals 14. Let's try out this formula here. Example 2, first it wants you to find the number of faces, vertices, and edges of this polyhedron shown, and then it wants you to check your answer using the Euler's theorem. So we'll just first count the number of faces. So we have 1, 2, 3, and 4, 5, 6, and then the sides 7, 8. So we have face, we have 8, and vertices we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And edges we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we use the formula to check. Eight plus 12 equals 18 plus 2, so we have 20 equals 20. Yes, works. Example 3. Is it possible for a polyhedron to have 16 faces, 34 vertices, and 50 edges? So now there's no solid, a polyhedron for you to look at. You can go ahead and use Euler's theorem. Faces plus vertices equals edges plus 2. So we have 16 faces plus 34 vertices. And we want to know if it equals 50 edges plus 2. So no. Example 4. Describe the shape formed by the intersection of the plane and the solid. So this is just a circle here. This would be the cross section. So we call this circle. And this would be a pentagon. This would be a rectangle. And this would also be a rectangle. So we're just using the base to help you. And this would be a pentagon. And the last one would be a triangle. And I could expand this section by asking you to find a missing side or even area.